Okay, hi everybody. Here's this extra practice that goes along with Notes 4-5. So that first notes video, I just gave you a couple, but the more of these you do, the better you will become. So this additional practice is part of the notes. All right, step one, set the equation equal to 0. So while I'm doing this, I'm going to put my terms in order from my highest degree down to my lowest degree. I'm going to add 18 to each side. All right, so let's look at what I have here. I have a cubic, but I have a 4 term, and it's looking like we've got some friendly numbers here. 3 and 16, maybe not, but I don't know if we can factor out a greatest common factor, maybe not. Let's go ahead and go to the graphing calculator. We'll enter in the equation, and we'll see if we can find some zeros to take out. Now, if you want to go to Desmos, that's fine. Type the equation into Desmos, 3x cubed minus 16x squared plus 15x plus 18. This 16 really messed me up. I thought 3 and 15 and 18 were friendly numbers. But then I realized that nothing pretty was going to come out. So this is why I went to the graph. Now, oh, look, I got a double root. So it crosses once and bounces. So there's my 1, 2, 3 x's. So I'm going to be able to find all real numbers. Let's go ahead and see where to look for an output of 0. All right, so it looks like at 3 is my only output of 0. All right, so I can jump right away to the end. I know that x is going to be equal to 3 and some other double root. So let's go see what I end up with. If I'm going to test that 3 is going to be a solution, I'm going to synthetically divide, and guess what I know is going to happen? I know I'm going to end up with that 0 there. All right, my coefficient for my x to the third, my coefficient to my x to the squared, my coefficient for my linear, and then of course my constants. All right, this comes down, and this is where I multiply, and then I add. So if you're unsure of some of this math, go ahead and get a calculator, because if you mess up here, you're kind of going to end up pretty much stuck. So I want to make sure I don't drop that negative. Okay, so that gives me negative 21. That's going to give me negative 6, negative 18, and I get 0. So I know that that 3 worked. This is no surprise. The only reason I'm doing this is because these are the coefficients that I need for my next level. My next level equation is 3x, and this is my constants, my linears, squared minus 7x minus 6 is equal to 0. So I'm going to go ahead and do a quadratic formula. I know it's a lot of work, but sometimes it's just easier than thinking about completing the square or trying to mess with factoring. Whether or not this will factor or not will make it an easy quadratic formula to solve. So I have my a is equal to 3, my b is negative 7, my c is negative 6. All my x's are equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'm going to jump right to my graphing calculator, and I'm going to type in my discriminant, 49 minus 4 times 3 times negative 6. Double check that I didn't hit any wrong keys. 121. Excellent. I had a funny feeling that was going to be a perfect square. 7 plus or minus the square root of 121 all over 6. So this is where I get my 2 other roots. Maybe it's not a double root. Let's check this out. X is equal to 7 plus or minus 11 over 6. So isn't that funny? It looked like a double root, but when I zoom in, this is cool. I can do zoom, and I can press Z box, and I can move my cursor and create a box. Did you know you could do this with the graphing calculator? and then whatever box you create, it'll blow up for you, and it'll be curious, I wonder why I didn't get a double root. We're going to think about this one. 7 plus, so this is going to be 18 over 6, and that simplifies to 3. There's my double root, everybody. I knew it was there. And then here's my second part. This is just my plus. X is equal to 7 minus 11 divided by 6. So 7 minus 11 is negative 4. So that's going to be negative 2/3 when I simplify it. How funny is that? It was 3 that was my double root. I should have thought about that. All right, I'll show you what I mean. You can see where it's going to bounce. I should have known it was 1, 2, 3 that was my double root. Here's my negative 2/3. So I can see both of those answers there. All right, let's do number 2. We'll go ahead and we'll set everything equal to 0. X to the 4th plus 2x cubed minus 4x squared minus 10x, and then we have my minus 5. I subtracted 5 from each side of the equation. So that's too many terms to do grouping. I don't see any greatest common factor. So I'll go ahead and enter my equation into my graphing calculator. X to the 4th plus 2x cubed minus 4x squared minus 10x minus 5. So you can type this into Desmos. That might be easier for you to see. And we'll go ahead and press graph. And when we look at that, oh, we've got some fun things going on. We've got 4 possible x's. So 1, 2, 3, 4. So this double root somewhere around here is going to show up. I'm going to look for my zeros and see if I see any outputs of 0. There's 1. That's good. That might be all I need. Looks like that's all I'm going to get. All right, so here's negative 1 is a 0, which means way down here at the end of my problem, I know x is going to be equal to, I have at least 1 0. Let's use that 0 to break down the rest of my problem. So negative 1, synthetically, I know is going to give me a 0. Let's talk about coefficients. 1, 2, negative 4, negative 10, and negative 5. I get each of these coefficients from each of these terms. All right, ready? 1 comes down, and then I multiply. Negative 1 times 1, and then I add. Multiply, add. Multiply, add, multiply, add. So I got my 0. Now here's what I wanted next. I knew this was going to work, but these coefficients are going to give me my next level. This is the constant. Here's my linear x's. Here's my quadratic x's and my cubic x's. I know my new equation, x to the 3rd, x squared, negative 5 minus 5. This totally looks like a factoring by grouping. If I have 4 terms and I can see a common factor, I'm definitely going to go that route. X squared comes out, x plus 1 is left. Negative 5 comes out, and x plus 1 is left. So I end up with 0 is equal to x plus 1 times x squared minus 5. This problem seems very familiar. Here's my second root of negative 1. X is equal to negative 1. X squared minus 5 can be equal to 0. X squared is equal to 5. X is equal to plus or minus the square root of 5. Why do I feel like I've done this one before? Guess what? Here's a double root. And here's my other two roots of 5, plus and minus. So I needed to find 4 times it crosses the axis. Here's where it bounces. I can go back and look at my graph at -1. That -1 is where it bounces. And then positive root 5 and negative root 5. All right, let's do this one. 0 is equal to, I don't have to manipulate my equation at all. And I'm not sure that this is a factor by grouping because I don't see a lot of friendly numbers. I can't take a 5 or a 3 out and nothing friendly going on here. So it's looking like my first step is the graphing calculator. All right, 5x cubed minus 27x squared minus 17x minus 6. Oh, I did it again. Darn it. I wish there was some way you could reach out to me and say, hey, you forgot to arrow out. Some calculators make you arrow out and some calculators don't. All right, let's take a look at the graph. Looks like this is going to be our only 0. These are going to be imaginary. That means when I go to do my quadratic formula, I'm going to have a negative underneath the radical sign because it never crosses the axis. So we've got to go find this one answer. So I'll pop down to the positives. It looks like that's where it was. There it is at 6. Okay? So I know that for this one, I can go right down to the end. I know that x is equal to 6. And then I'm going to have some imaginary value there. All right, so that means that 6 works. If I know 6 works, I can go ahead and set myself up. Let's get your coefficients. 5 is your cubic term. Negative 27 is your squared term. Negative 17 is your linear term. Negative 6 is your constant. 5 comes down. Multiply. 30. Negative 3. Nope, positive 3. Whew, that was close. 18. Positive 1. 6 and 0. Now, you saw I almost made a sign mistake. If I ended up with not having 0 here, I know I would have had to go back and fix and find what my mistake was. This is my constant. This is my linear level. And here is my quadratic level. So my new equation is 5x squared plus 3x plus 1. It's time to do my quadratic formula. I know that A has a value of 5, B has a value of 3, and C has a value of 1. All the values of x are equal to, let's do the quadratic formula, the opposite of B, plus or minus the square root of b squared minus 4 times a times c all over 2a. X is equal to negative 3 plus or minus the square root. Let's go to the calculator and have them do the discriminant for us. So we'll go ahead and say, all right, calculator, what is 9 minus 4 times, oops, 9 minus 4 times 5 times 1? Negative 11. I told you it was going to be negative. Over 10. All right, so I don't have any friendly numbers here at all. So believe it or not, when you have no friendly numbers, there's less work to do. So the I comes out of the radical. Square root 11 I cannot simplify. And 3 and 10 don't have any friendly numbers. So guess what? These are my next two roots. Negative 3 plus or minus I root 11 over 10. That's it. That's all I need to do. Because it was a cubic equation. The graph showed us it crossed once and then never touched the axis, and that's what happens with our imaginary roots. In fact, this is what we're going to start talking about next, is when we talk about these graphs, being able to look at what happens as a result. Here's my one real root, and this bump here that never crosses the axis, that's this value there. All right, Look, they gave us, so we don't need to graph, they gave us our 1, 0. All right, so I have 0 is equal to 4x to the third plus 9x squared minus 52x plus 15. Guess what? They told us that one of our zeros is negative 5. That's good news. So now we have a place to start. We can go ahead and say, okay, if I put negative 5 in my synthetic box, I know I'm going to get a 0 out with coefficients of 4, 9, negative 52, and 15. 3, 2, 1, none. So I'm good with my terms of x. 4 comes down, negative 20. When I add that, I get negative 11. So I get positive 55, positive 3, negative 15, and it works. So I did a good job. Remember, this is all that I wanted next. So the next level of my quadratic is going to be 0 is equal to 4x squared minus 11x's plus 3. Now, we never graphed this. So I don't know if my next answers are going to be imaginary. So if I wanted to, I could take the time to come. I could even graph this. Or I could just jump into the quadratic formula because I'm so used to doing that. So A is equal to 4, B is negative 11, and C is equal to 3. Quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. I'll be surprised if this works out pretty, but let's go ahead and try it. Let's figure out our discriminant. 121 minus 4 times 3, 73. Yeah, that's not a pretty one at all. So we have x is equal to 11 plus or minus the square root of 73. I'm pretty sure 73 is prime over 8. So I can't break down my radical. I don't have any friendly numbers. I don't have a negative under the radical. So guess what? Those are my next answers. 11 plus or minus the square root of 73 over 8. So here we go. Are you ready? I needed to find 3 answers because I have 3 x's. Here's 1. And then this plus or minus gives me my other 2. All right, good job with that practice. When we look at the back, here's a analyzing graphs that's worth a conversation. And we'll do that on a separate video.